Hold, please.
I got this time.
I'm so silly. I split it into 2 slideshows. It's crazy. All right, here we go. Let's go. Let's get this done. Bingo. We're looking for the area of that washer. And so we could have spent 20 minutes figuring out how to calculate that area / volume, but you're all fairly bright. So you realize that if I take that rectangle that's not touching the axis of revolution, that's important. If it's not touching the axis of revolution, then you're going to get a washer. And if I was to say to you, hey you, how would you find the area of this guy? You would tell me. Say it loud and proud, Eric, so everybody in the universe can hear you.
To subtract the one inside from the bigger.
Right. So for discussion purposes, we call this distance way out to the furthest point capital R, and we call the distance to the closest point little r. Big R is defined as the farthest distance from the axis of revolution to a point on the rectangle. Little r is considered the closest point between the axis of revolution and the rectangle. Now, I rewrote this in a different form, but what Eric described was actually pi capital R squared times W minus pi times little r squared times W. I just cleaned it up a little bit, because I can. And based on what we did with disks, we know that W is going to become dx, because that's way too fat of a disk or a washer to use. We need a real skinny one. And then everything goes from there. Hopefully, you don't have trouble finding capital R and little r on a graph. But I have a bunch of examples to help you work through that. Okay? Makes sense? Yeah. Okay, good. Oh, that's okay, stop that. Let's try this. There we go. So again, we've seen this eye hole from a villain's mask. And if you spin that around the x-axis, you end up with that funky, weird-looking frustum with a fat stuff inside of it thing. That's a technical term, by the way. You all know what a frustum is, right?
No.
Molly, you know what a frustum is, don't you? Who else did I have for Geo? Eric?
I call the shape of a vacuum cleaner.
It sounded like you just said I called the ship a vacuum cleaner.
The shape.
Oh, the shape. I'm sorry. The shape of that's a shape. That's a vacuum cleaner.
Yes, I had it before. Yeah.
All right. So, quick geometry lesson. If you take a cone and you slice off the top is called a cone. Good. The bottom is called a frustum. In my geometry class, we found the volume and the surface area of the frustum. And it was fun, wasn't it, Smitty? And it was fun, wasn't it, Smitty? Good answer. Okay. If you had calculus freshman year, you would find that using the calculus method is actually a lot easier than using the geometry method. Okay. So, here's my shape, this is blue, this blue shape over on the left, and that representative rectangle can be seen in there, and this graphic uses a big fat representative rectangle. It's okay, you can see it clearly. But again, you also see in that picture labeled where capital R is and where lowercase r is. So again, your goal, just like with disks, is to find the volume of one washer and then integrate all the possible washers using an integral. Okay, here's another example. This is the area between two curves, f of x and g of x. You did that in section 1 when you were finding the area of that puppy. But we don't care about the area, we care about the volume. So if you go all the way to the right, that big fat blue rectangle is the representative rectangle. When you spin one of them, you get that washer. You integrate over all the washers and you get the red thing in the middle. You understand where we're going with this, yes? Do I need to go back to the cool program that I showed you and spin it? Okay, good. I didn't think so. Let's just get into some calculations. It's there. We can do it if you want. No? Did somebody say I want to see it?
No, nobody did. Slow.
It'll take 2 seconds. So, there's what we're going to do. Now, for those of you that are memorizers, this is going to cause some problems. I find that people that just try to memorize get confused between discs and washers. It's better if you understand where these formulas come from. Okay. So, this washer method is the volume of a disc minus the volume of a disc. As Eric said, it's the circle minus the outside circle minus the inside circle. If you want to break that into two integrals, you can. There it is in one nice, pretty little form. If I rewrite it, for instance, I would get this. Okay, that would just be the disk formula that we used before, but now I need to subtract the hole in the middle, which would also be a disk. Whichever form you want to use, I don't care. Big radius squared minus little radius squared. Notice, it's not big radius minus little radius quantity squared. It's big radius squared minus little radius squared. Enough talking. Let's start rocking. Yep. Okay. Here we go. The cat's eye thing. Top function is the square root of x. The bottom function is x squared. They meet together and make that little cat's eye thing, and we'd like to know the volume of that funky blue shape over on the right. Okay? So, first of all, the graph was kind enough to give us the point of intersection at 1, 1 and 0, 0. So that's one less thing we need to worry about. I still need my integral. Okay? And you can take this in stages, and depending on how good you are with this or how comfortable you feel with it, you might be able to go right at it from the start. So the volume of that figure would be pi times the integral. I'm taking washers from 0 to 1. My first washer would happen at 0. I'd keep adding washers up until I get to 1 and then stop. What's big R? Okay. Again, think of it this way. Big R is the farthest distance from the axis of revolution to the furthest point on the rectangle. This, as it's labeled, is big R, which is the square root of x. Square root of x squared minus little r. Little r is the closest distance. Here's the closest distance, x squared. Quantity squared. I don't know what just happened. D. There's no wiggle room over there. That button's about 4 times bigger than the actual button. DX. Faulty construction.
You should write.
I should. A nasty
I
one.
got some choice words.
Right. Dear Microsoft. Like they're going to care about some lonely schmuck. All right, we good? Easy limit of integration defined if you're doing it by hand, because it becomes x minus x to the 4th dx, which you're all more than capable of solving, or fm into. Doesn't matter. Questions? Did that already. Did that. Oh, I did it by hand. Look at that. Cool. Plug in 1, plug in 0, get 3 pi over. What happens when you go over? Oh, yeah. So we did this already for discs. Now we can also do it for washers. I don't want to make a big deal out of this because you're still falling back on the standard. Top minus bottom, right minus left. Anytime you want to know how tall something is, it's going to be top minus bottom. Anytime you want to know how wide something is, right minus left. As I said there. Okay, so this guy. We have 3 functions here. Well, we have a whole bunch of things, actually. We have x squared plus 2, which is that red upward-facing parabola up at 2. We have a line 1/2 x plus 1. That's the royal blue guy. And then we have the 2 lines that define a region, and that is 0 to 1. This is 0, obviously, and this is 1. So we're going to take that monster and revolve it around the line y equals 3, not around the x-axis. Okay, so we're going to take it around this line. Okay, question number 1. Where is capital R? Conrad, thank you for saving us.
The blue line?
Okay, 2.
All the way to the left.
Well done. It's a little hard to see. It's right there. Okay. From the axis of revolution to the furthest distance away on the representative rectangle. Conrad, let's see if we can put you on a roll. Where's little r?
Red line to black line.
Uh-huh. Hot diggity. Okay, let's get some other semantics out of the way. We're going to take washers from, in other words, what are my limits of integration? 0 to 1. Beautiful. Easy peasy, lemon squeezy. Okay, so we might as well start building this bad boy. Pi times the integral from 0 to 1 of capital R squared. So, now we need to figure out how big capital R is. So I will ask you, how big is capital R? Well, this is awkward. Emily, are you on your own shirt? I'm stalling for you to answer the question, so. Yeah, you should highlight it so you can say again? Also known as 3
minus the blue line,
which is
1/2 x plus 1.
good. Top minus bottom. Be very careful. Shouldn't have been his Elmer Fudd. Be very careful. Hunting rabbits. Be very careful. I'm doing calculus. Okay. Capital R squared. So be careful about 2 things. Number 1, be careful with parentheses. Number 2, be careful that you remember to square that. We're almost there. I can feel it. What's little r? 3 minus the quantity x squared plus 2 quantity squared. And don't forget that dx because that denotes the thickness of your washer. Oh, that was fun, no? You don't want to be squaring trinomials. You're all bright. You can figure out what 3 minus 1 is. Hopefully. Well, if not, you got a calculator. Or Desmos. Or use your fingers. Whatever works for you. Okay? Questions? Again, I'm not so concerned about solving the integral because at this stage you should be able to solve that. Or if nothing else, you should be able to FN int it. Okay, I'm more concerned about setting it up. And notice, what did we go back to? Top minus bottom. Top minus bottom. If we go with a horizontal rectangle, maybe it's easier to do it horizontally, or you're spinning around the line x equals 0, then everything will be in terms of y. This is fun, right? I think that matches what I wrote. I'm going with it. You do this one with your group. Never mind. I forgot I put it in the slideshow, and you weasels will just puke it back at me.
Hey, yo, let's go, guys.
That's my fault, 100%. Let's review what's going on here. I've got a function y equals x to the 5th. Do you know what that looks like? Graph it quickly. Desmos or calculator. Yeah, it looks like a cubic function on steroids. Beautiful. And then the lines y equals 1 and y equals 32. I will tell you overall, the biggest mistake that people make in this stuff is they draw the line y equals 1 as a vertical line. Y equals are horizontal lines, x equals are vertical lines. Don't be one of those people. So when I solved this problem, I drew a sketch and I realized it would be easier to do it with a horizontal rectangle because I'm revolving around the y-axis. We don't know how to do it any other way because we're not doing the shell method. Yeah. Okay. Which means everything needed to be in terms of y, so I solved for y. If y equals x to the 5th as your function, you can solve that and get y to the 1/5 equals x. And then go from there. Okay, and we end up with that, and I cheated in FN int because I didn't want to take the integral of y to the 2/5. Okay, doke. We good? All right, so let me give you some hints. If you start a problem like this, and by the way, you might want to make some notes here. This might help you. You need to decide number one. Well, first things, number one, I would draw a picture if you can. Number two, are you going to use a horizontal or a vertical rectangle? If your rectangle is vertical, everything is in terms of x. If your rectangle is horizontal, everything is in terms of y. Next question. Is my representative rectangle touching the axis of revolution? Or is it not touching the axis of revolution? If it's touching, then you're going to use the disk method. If it's not touching, you're going to use the washer method. Now, one caveat, because people like to argue with me about this. If I go back to the cat's eye picture, you'll notice my very first rectangle there is technically touching the axis of revolution. That's cheating. Okay, it's got to touch it anywhere. Not touching, washer. Touching, disk. Hold, please. Getting caught up. Thank you. Okay? So if you do go to a disk method, it is the volume of the disk integrated. How do you find the volume of the disk? It's the area of the circle times dx, or dy, depending on what method you're working in. If it's the washer method, then it's the area of the washer, big radius squared minus little radius squared times pi. times dx, or dy. And then you probably want to write it down again, if it hasn't been burned into your brain yet, top minus bottom, or right minus left. Top minus bottom when you're working in terms of x, right minus left when you're working in terms of y. Okay. Good. Awesome. Oh yeah, more fun. Ooh. Last comment. I included this one only because there are certain situations where you may have to break it into two parts. We did this when we were calculating area. The same thing happens when you're doing volume. When I get up to x equals 1, I have to change my integral because my left-hand function changes. Anytime the top or bottom changes, anytime the right or left changes, you need a new integral. Okay. Find the volume of each of these two things and go. Now, I'm a geometry teacher. I don't know if you knew that. So I wouldn't use calculus for the stuff below 1. Because what shape is the stuff below 1? No. When you revolve it, it's a cylinder, correct. So I would just calculate the volume of the cylinder. And then add that to the funky weird shape for the bowl cup looking thing up on top. But if you want to do calculus, go ahead. That's what makes this such a great country. Right, the power right on. Blah, 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 done.
Washer method.
Man. Washer method. Man. Washer method. Man.
Dryer.
No, it's not a dryer, it's a washer.
It can be a dryer though.
It's not, it's a washer. It's a front-loading washer, Mason.
Wait.
How many of you at home have a front-loading washing machine? Okay, thank you.
What? I don't.
Mr. Bridie, do you know who this is? Hey everybody, it's Mr. Bridie. No, good guess though. It's Method Man.
I do not believe that.
It's a washer.
It is called washer method, man.
Yeah, washer method, man. I get no respect. No respect at all. That's it. I'm just going to end every slideshow now with like, do your homework, kids. Be all that you can be. Hang in there. I'm going to have a picture of a cat. You know the cat hanging on a branch?
Yeah.
And it says, hang in there. Yeah, I'm going to start including those. Don't appreciate this. Or it's just going to be a blank screen. You know how long it took me to find a picture of Method Man? About 3 seconds.